Hi, welcome to the video solution for past paper. This is Edexcel IAL Mathematics paper P1 January 2020. So let's start. Question number 1. Find in simplest form integral of 8x cubed over 3 minus 1 upon 2 root x minus 5 dx. It is a straightforward question of integration, and you know that integration is a technique which is a reverse process of differentiation, in which if you have some variable power n dx, so you can integrate x to the power n as we increase power by 1 n plus 1 divided by n plus 1, plus always we write sign of integration. So if you have x to the power n, this is the formula. So we need to integrate, or we need to apply this approach in each and individual term. We have three terms here, but remember, we cannot integrate if some variable is in denominator at this stage. That means we cannot integrate this root x which is in denominator. So before applying integration rule or formula, we will have to send this root x in numerator so we can apply the formula. So now we are simplifying. So 8 upon 3 x cube minus 1 upon 2 x to the power minus half. I just sent root x in numerator, and minus 5, this is dx. And now we are going to integrate each term. So integration of x cube is 8 upon 3 x4 upon 4. So I just added 1 in 3 and divided by 4. So x4 upon 4 minus half x to the power minus half plus 1, which is half, divided by half, and minus integration of 5 is 5x plus c. And then rest of the steps are just simplification. So 4 1s and 4 2s, and then 2 and this 2 gone. So you can say that the final answer will be 2/3 of x4 minus x to the power half minus 5x plus c. This is final and simplest form of the integral. Question number 2. Given y equal to 3 to the power x, express each of the following in terms of y. Write each expression in its simplest form. So we will have to write all the terms in terms of y. So you see we have expression 3 to the power 3x. Now 3 to the power 3x, so 3 to the power 3x can be written as 3 to the power x whole power 3. And now this 3 to the power x is in fact y. So I can replace 3 to the power x with y. So you can say that this is y, so y cube. This is 3 to the power 3x in terms of y cube. This is your part A. Part B is 1 upon 3x minus 2. So again you will have to think the way that you can write 3 to the power x separately. So this 1 upon 3x minus 2 can be written as 1 upon 3x into 3 to the power minus 2. I just separated the power on the base of 3. And then this 3 to the power minus 2 can go up. It will become 3 square divided by 3 to the power x, and this 3 to the power x is y. And now finally 3 square is 9, so 9 upon y. This is the second expression in terms of y. So 9 upon y. And part C is 81, 9 square, 9 to the power 2 minus 3x. So you see we have 81 here, we have 9. So we know that 81 can be written in terms of 9. So you can say that 81 can be written as 9 square divided by, and again I am splitting this power 2 minus 3x over 9. So I can say that 9 square into 9 to the power minus 3x. And then you see that 9 squares are cancelled, and we have only 1 upon 9 to the power minus 3x. And then you can send 9 to the power minus 3x in numerator to make it positive power. So when it goes up, so it becomes 9 to the power 3x. And then this 9, because every term or every expression should be in terms of 3 to the power x. So 3, we need 3 as a base here. 3 as a base. So I can write this 9 as 3 square. So you can think this 9, just this 9 as 3 square. And then over 9 we have 3x. Clearly you can say that you can write this whole expression as 3 to the power x whole power 6. So 2 times 3, so 6x, or you can take 6 up, x down, and 3 to the power x is y. Now finally this is y to the power 6. This is the last expression in terms of y to the power 6. Question number 3. Figure 1 shows part of the curve with equation y equal to x square plus 3x minus 2. The point P 316 lies on the curve. Find the gradient of the tangent to the curve at P. Remember, if you are given some equation of curve like this, and you need to find gradient of the tangent. So gradient of the tangent is nothing but derivative of the function dy by dx, or you can say f dash of x. It depends in what form the function is given. So if you differentiate this function, or this equation, which is equation of the curve, so derivative of this function or equation will be the gradient of the tangent line. So for part A, to find the gradient of the tangent, you need to find dy by dx at that particular point. So first we are going to differentiate. So dy by dx is equal to 2x plus 3. So this is gradient of tangent at any point on the curve, but we need to find gradient of the tangent at that particular point here. So we need to substitute, or we need to put the value of x in place of x in the differentiation. So dy by dx, which is the gradient at point 316, 3 comma 6 is your choice. That's how I write. At point 316 is 2 times of x, and value of x in the point is 3. So 3 plus 3, which is 2 times 3 is 6, 6 plus 3 is 9, which is 9. So this is gradient of the tangent at point 316. The point Q with x coordinate 3 plus h also lies on the curve. Find in terms of h the gradient of the line PQ. write your answer in simplest form. So we have another point Q on the curve with the x coordinate 3 plus h. So you can imagine, suppose I can take a point Q just like this. So now let's see, this is point Q, assuming. So this is Q. And we need to find gradient of PQ. So PQ is the line. You can visualize that if you join P and Q, so we have a line, something like this. And this line is passing through 2 points on the curve. And remember, this line which is passing through 2 points is called secant line. So this is a secant line. Secant line. Okay, so we need to find gradient of the line PQ. So we have x coordinate of the point Q, but we don't have y coordinate. So first we are going to find y coordinate of point Q, and then we can use the formula for gradient, which is y2 minus y1 divided by x2 minus x1. So let's figure out y coordinate of Q. So you can say that the y coordinates of Q for Q. So y coordinate we can find just substituting this x value or x coordinate of Q in place of this x in the original equation. So y is equal to x square, which is 3 plus h. So y is equal to 3 plus h whole squared plus 3x, and x is 3 plus h minus 2. And we need to simplify this whole equation, which is y in terms of h. Once you simplify this, so y would be equal to h square plus 9h plus 16. This is the final equation once you simplify. But remember, don't forget to open the perfect square formula. So this is value of y is equal to h square plus 9h plus 16. So now you can see that this is the y coordinate of point Q. So for your understanding, I'm just writing that Q can be written as 3 plus h comma the y coordinate, which is h square plus 9h plus 16. And now the gradient of PQ. So gradient of PQ can be found using just y2 minus y1, because we have now 2 points. One point is P and the other point is Q. So we can find y2 minus y1. So you can do that. I'm just taking this as x2 y2, and this one is x1 and y1, just so 2 points. So y2 minus y1 give me h square plus 9h plus 16 minus 16. So y2 minus y1 divided by x2 minus x1. So 3 plus h minus x2 minus x1. So x1 is 3. And now 16s are gone, 3 also gone. So only left behind is h square plus 9h divided by h. If you take h common from numerator, so h is common, so h plus 9 divided by h. H again gone. So final the gradient, which is, if I use m for gradient, a general symbol, so m of PQ is h plus 9. This is gradient of the line PQ in terms of h. Part C, explain briefly the relationship between the answer to B and the answer to A. If you see, part A was all about find the gradient of the tangent. So gradient of the tangent, which is we found as 9. You see here. So gradient of the tangent was 9. In part B, we found the gradient of PQ, and I told you that the PQ is a line passing through 2 points from the curve, and this line is called secant line, and the gradient of the secant line is h plus 9. Now if you see, if you make this h smaller, like you say that, since this is, so you can say that m of PQ is gradient of the secant. If h is becoming, or you can say h is coming to 0, so h approaches to 0. If you make h really small, is not 0, it is really small. That's the meaning of this arrow. H approaches 0. It is not 0, just very small. So if h is very small, then you can put h as a 0 here. So mpq equal to 9, which is as same as the gradient. That means the measurement, see, so you can say that then gradient of secant would be equal to gradient of the tangent at P, and this is only possible if you make h small. Question number 4. Figure 2 shows the plane view of a house ABCD and a lawn ABCDA. Okay, that's how you see. This is a rectangle, and okay, kind of quadrilateral, a house, and shaded area of a lawn. ABCD is a rectangle with AB equal to 16. So AB, this is 16, and APCOA is a sector of a circle center O with radius 12 meter. So with center O, the point O, center O, that means this is 12. If this is 12, clearly this is 4. It should be 4, the DO. That's how I figure out 16 minus 12, 4. Okay. The point O lies on the line DC as shown in the figure 2. Show that the size of the angle AOD is 1.231 radians to 3 decimal place. We need to find angle AOD. So AOD, this is the angle that we need to figure out, and this angle should be 1.231. Now you see that this is 4. This is DO is 4, and OA is also 12. And the reason is because OA is the radius of this circle. Because OC is 12, so OA should be 12. And now you see we have a right triangle with 90 degrees. So this is your hypotenuse and this is your adjacent. So we can find this angle theta. Suppose this theta, this small angle, using cos. So cos theta is equal to adjacent over hypotenuse, which is 4 upon 12. And then theta is equal to cos inverse 4 upon 12, or 1 upon 3, because 4 divided by 12, sorry, 4 is divided by 12, so 1 upon 3. And then you can find theta here, just find the cos inverse. But remember, generally what happens is students get confused, or keep forgetting to change the calculator from radian to degree, because we need to give answer in radians. So you have two choice. If your calculator is in degree, so this answer will be, whatever the answer is, this answer will be in degree, and then you can change this into radian later on. But in my opinion, you must have a habit to keep changing from radian to degree. So make sure that you use a correct mode of calculator. So in my opinion, you should convert this your calculator in radian and then find cos inverse. So your answer will directly be 1.2309, and you round it off to 3 decimal place, so theta would be equal to 1.231. That's how you figure out the theta. This is your part A. The lawn ABCDA is shown shaded in figure 2. Okay, so find the area of the lawn in meter square to 1 decimal place. So we need to find area of this shaded region. Clearly, if you figure out that this, if you include this triangle, complete triangle with the shaded one, so this is a complete sector. This is a complete sector that we can figure out the whole area of this sector with the angle 1.231 plus pi. So total angle is pi. So we know that the area A1, this is the area of the sector, which is half of r square of theta. R square of theta. In this case, r square, r is the radius, which is 12 square theta. This theta is the angle of the sector, and this theta is the total angle including the angle of the triangle. So theta would be pi plus 1.231, and then when you solve this, so your area would be equal to 314.83, and dimension is meter, so this is meter square. And then finally, the required shaded region is the area of this triangle, the green one, is subtracted from the area of the sector. So total area, now you can say that area of triangle A2, area of triangle AOD. So area of the triangle A2, area of the triangle, you can use your own symbol. So this is I am using formula that is half of OD into OA sine of 1.231. What is this formula? Remember, if you have any triangle with side A, B, and C, and suppose if you need to find any angle in the triangle, like suppose this is the angle which is given, suppose theta. So you can use an approach that the area of this triangle can be found by using area half of the two sides in which angle is included. So you can say half of B and C are the two sides in the triangle in which the angle is included. So you can say half of B into C sine of theta. That's how I'm using, because I know that this is 4 and this is 12. And this angle is included between these two sides. So half of length of OD and length of OA times of sine of theta. That's the formula that I use here. So you can say that A2 will be equal to half of 4 into 12 into sine of 1.231. So A2 will be equal to 22.63 meter square. Finally, area of the shaded region A is A1 minus A2. And if you subtract these two, so area A would be equal to 292.2 meters square, because we need to give answer to one decimal place. So 292.2 meters square. This is the area of the shaded region. Part C is find the perimeter of the lawn in meters to one decimal place. So perimeter of the lawn. Okay. So now let's see how do we find the perimeter? Perimeter is the total length. So we know that we have this total length, which is 16. Out of 16 we have 12, 4 here, and then okay, this is 12. So using these two we can figure out the third side of the triangle using Pythagoras theorem. So you can imagine we have remember this 16 is the total from D to C, or it's better if I write, otherwise you will get confused, 12 and 4. So this is 16 here. Okay, so now the idea of the perimeter is, perimeter of the shaded region P is AD, length of AD, plus length of CD or DC, whatever you say, CD, plus the arc length of APC. This is the arc length. And now AD is found using Pythagoras theorem. So you can say that this AD is, you can do like AD is 12 square minus 4 squared root. This is your AD. And if you find AD, it will be 11.3. And CD is 16. Okay, so 11.3 plus CD is 16. And what about APC? This is arc length. And for arc length, if you remember, S is equal to R theta. S is the arc length and R is the radius, theta is the angle. So we need the arc length APC and we need that whole angle. So you can say that R is the radius, which is 12 times of theta, and theta is pi plus 1.231. And if you solve this, perimeter would be equal to 79.78. And this is rounded off to one decimal place, so 79.8 meter. That's how you can find the perimeter. Question number 5. Question number 5. Find using algebra all solutions of 20x cubed minus 50x square minus 30x equal to 0. This is a cubic equation without constants, so easy to solve because we can take 10 and x common from left hand side. So 10x is common. So inside we have a 2x square minus 5x minus 3 equals 0. Now we have two factors. So one factor is 10x, which is equal 0, and second factor is 2x squared minus 5x minus 3 equals 0. So from this first factor 10x equal to 0, the first solution we can find x equal to 0. And for the rest of the solution we need to solve this quadratic equation, and it's easy to solve because we can factorize. So 3 times 2 is 6, so we will have to make factor of 6 so that these factors can be subtracted to have minus 5 as answer. So factor of 6 will be minus 6 and plus 1. So we can write this quadratic equation as 2x square minus 6x plus x, or 1x minus 3 equals 0. Now we have 4 terms. We have first 2 terms, we can take common 2x, and from this one we can take common 1. So we take common 2x from the first 2 terms, so 2x is common, and then x minus 3 plus rest of the 2 terms we take 1 common, so x minus 3 equals 0. Finally we have 2x plus 1, and we have x minus 3 equals 0. Now we have two solutions. So 2x plus 1 equals 0 and x minus 3 equals 0. From here we have x equal 3. This is the second solution, and from here we have x is equal to minus 1 upon 2. This is the third solution of the equation. Part B saying hence find all real solutions of this equation. So 20 plus 20 times of y plus 3 to the power 3 by 2 minus 50 y plus 3 and minus 30 y plus 3 half. Now if you compare y plus 3, y plus 3 and y plus 3, clearly in given equation we have 30x, and here we have a 30 times of this. So we can say that since y plus 3 to the power half gives us x, so we can substitute each value of x one by one and see that whether we have a real solution or not. So let's suppose for x equal to 0, for x equals 0, you substitute x here, so y plus 3 to the power half equals 0. Clearly when you solve it, so you have y equal minus 3. Clearly this is a solution, because if you put y equal to minus 3 in original equation, so you have minus 3 plus 3 equals 0, which is 0. That means this is the solution. Now let's just talk about second value for x equal 3. This is the second equation, or second value of x. So y plus 3 to the power half gives us 3. And then when you solve this equation for y, so you need to take a square. So y plus 3 is equal to 9, and then y is equal to 9 minus 3, which is 6. And again, if you recheck your solution, substitute y equal to 6 in the given condition. So 6 plus 3 is 9 to the power half root, which is 3, so it is satisfied. So y equal to 6 is our second solution. Now what about f for x is equal to minus half. And now if you substitute x equal to minus half, y plus 3 to the power half is equal to minus half. Clearly there is no value of y that gives us negative half as a root of y plus 3 to the power half. Or if you are not understanding, I'll just give you a glance, meaning we cannot use x equal to minus half. Why is that? You will understand soon. Let's solve this equation for y. When you solve for y, you have y plus 3 is equal to 1 upon 4. And then y is equal to 1 upon 4 minus 3, and then minus 11 upon 3. So y is minus 11 upon 4. This is the value of y. But if you recheck your solution after substituting y equal to minus 11 by 4 in this equation to check whether you have a right solution or not. So you will say that you substitute here and you will have minus 11 upon 4 plus 3 is equal to half. It should be equal to minus half. Let's check, solve left hand side. So minus 11 plus 12. So minus 11 plus 12 is 1 upon 4 power half equal minus 1 upon 2. Clearly half of square root of 1 upon 4 is half. Half equal minus half. That means which is not possible. So y cannot equal minus 11 upon 4. So we have just two solutions for second equation part B, y equal to minus 3 and then y equal to 6. Question number 6. The line L1 has equation 3x minus 4y plus 20 equals 0. The line L2 cuts the x-axis at r 80 and is parallel to L1. Find the equation of L2, writing your answer in the form of ax plus by plus c, where a, b, and c are integers to be found. So we need to find equation of line L2, and remember L2 is parallel to L1. This is our L1. So if two lines are parallel, then their slopes are equal. Slopes or gradients are equal. Meaning if a slope of line L1 or gradient of line L1 is M1 and gradient of line L2 is M2. So because of the parallel condition, we say that M1 is equal to M2. So if we figure out value of M1, meaning gradient of line L1, so we can have a gradient of L2. So we have equation ax minus 3x minus 4y plus 20 equal to 0. Remember, you have two choices. If you have an equation in the form of ax plus by plus c equal to 0, you can find gradient using two different techniques. One is you can rearrange this equation in the form of y equal mx plus c, and this coefficient of x will give you gradient of the line. Or the second option is the gradient of the line, you don't need to rearrange. Gradient of the line you can find directly, m is equal to minus a by b. So a is the coefficient of x here, a is the coefficient of x, and b is the coefficient of y if the equation is in the form of ax plus by plus c equal to 0. So don't need to rearrange, you just substitute minus a by b. So if you use this approach, so you can say that for part A, m1 would be equal to minus a by b, and a is 3 and b is minus 4. You see, this is your a and this is your b. So this is minus 4 and minus minus gets cancelled. So m1 is equal to 3 by 4. This is the gradient of your line, 3 by 4. Now clearly, so this is also equal to m2. So you can find equation of the line L2 because the point on L2 is given. So we can use slope point form or gradient point form. Y minus y1 is equal to m times of x minus, this is x minus x1, where x1, y1 are the coordinate of the point on the line, m is the gradient of the line. We are talking about L2, so y is y minus y1. y1 is the y value of the point, which is 0. and m is the gradient of the line, which is 3 by 4. X minus x1, x1 is 8. So x minus x1, which is 8. And we need to write the equation in the form of ax plus by plus c equal to 0. So you just cross multiply. You say that 4y is equal to 3x and minus 24, and rearrange this equation. So you can say 3x minus 4y minus 24 equals 0. This is the required equation of your line L2, part A. Now the line L1 cuts the x-axis at point P and the y-axis at point Q. Given that PQRS is a parallelogram, find the area of the PQRS. So if you see that the line L1 is cutting axes at point P and Q, that means P and Q, these are x and y intercepts respectively. So we need to find the coordinate, how do you find the P and Q? So if you put y equal to 0 in the given equation of L1, then we have a value of x, which is x-intercept. So I'm just sketching the curve so we can have an idea. So for L1 is 3x minus 4y plus 20 equal to 0. So if y equal to 0, that means y equals 0. This implies that 3x plus 20 equals 0. That means x is equal to minus 20 upon 3. This is x-intercept, remember, meaning this is the point P. And for Q, if x equal to 0, this implies that, put x equal to 0 in equation, so minus 4y plus 20 equals 0, and then y is equal 5. This is y-intercept, that means this is your point Q. So you can visualize your line as this is y-axis and this is x-axis. So your y, this is not 0, sorry, this is y equal to 5. This is not 0, y equal 5. So this is 5, because if you solve this, y equal to 5. That means y-intercept is 5. So y is 5 here. This is 5. And this is minus 20 over 3. Minus 20 over 3 is 6 point something. So you can imagine, okay, fine. This is your point Q. And this is point P. And you can say that your line is something like this. This is your line. This is your L1. And if you visualize your point R, which is 8, 0, on through which line L2 is passing, so 8, 0 will be somewhere here. This is point R, 8, 0. And this is point Q, which is 0, 5. And this is point P, which is minus 20 by 3, 0. Now they are saying that P and Q are intercept, and given that PQRS is a parallelogram, find the area of PQRS. So we need to find the area. So PQRS, this is the parallelogram. So this is R. That means your parallelogram looks like this, something like. So this is your point S, something. This is a parallelogram. This should be your point. Now, if you need to find the area of the parallelogram, so the idea of parallelogram is we can find area of the parallelogram by finding area of these two triangle, this triangle and this triangle, and then add these together and times 2. So we have a total area of the parallelogram. This is one method. So what I'm doing, I'm finding area of the triangle OPQ and area of triangle OQR, and then we will figure out how. So area of triangle OPQ, let's call it A1. So A1 would be equal to half of base into height. So base is 20 by 3 because it's all about length, into height. Height is 5. So this is the area. You can solve it. You can find it area A1, and then you will work out for A2. So area of triangle OQR, which is A2. Let's say A2 is half of the base, which is 8, times height, which is 5. This is area of A2. And then the sum of the area sum of the area of the two triangle above the x-axis. So A is equal to A1 plus A2. If you add these two, so your answer will be equal to, this is 2, 4, 5. So this is 20, and this is minus 50. No, not minus, of course, 50 by 3. So sum of these two would be 60. So 50 by 3 plus 60, so 110 by 3. So this is the area of first two triangle above the x-axis. So total area will be, so area of parallelogram PQRS will be twice of the area. That means 220 divided by 3. This is the final area of the parallelogram. Part C, find the coordinate of S. Okay, if you need to find the coordinate of S, which is x comma y, that's what we need to figure out. Now if you see, this is a parallelogram and this is origin O. So with respect to origin, you know that coordinate of P is 20 by 3 unit away on the left hand side. Or from P, if I ask you to find the distance of O and P, so that distance should be 20 by 3. So from Q to O, that distance, the horizontal one. Similarly, if you apply the same approach, of x coordinate of S, like here, if I ask you what should be that distance, that distance should be 20 by 3 from R. So let's suppose in diagram, if you mark this point as on the x-axis, let's call it point, maybe you can give any symbol like x, maybe capital X. So you say that the coordinate of x, if we can figure out, so the total length is 8, and this one is 20 by 3. So the coordinate of x will be, so the x coordinate of s, so x will be equal to 8 minus 8, which is the total length from origin to point R, 8 minus 20 by 3. So 8 minus 20 by 3. So you can say this is 4 upon 3. This is the x coordinate. And the y coordinate, y equal, because this is axis, so q is 5 unit above from origin, so s should be 5 unit below. That means it must be minus 5. So coordinate of s are 4 by 3 comma 5. That's how you can work out the coordinate. There are some other option to find the coordinate. You can find the gradient of qr and the gradient of which will be a number qr, because all are numbers. So gradient of qr which will be number, and the gradient of ps which will be in terms of x and y. So these two gradients should be same. And the other option is you can find the gradient of pq, which will be a number, and then the gradient of rs, which will be in terms of x and y. So you have two algebraic equation in terms of x, y. You can solve these two equations simultaneously to find value of x and y. So that's how you can try yourself. Question number 7. Figure 3 shows part of the curve C1 with the equation y equal to 3 sine x, where x is measured in degrees. The point P and the point Q lies on C1 and are shown in figure 3. Okay, so this is the curve of y equal to 3 sine x. 3 is the amplitude. Amplitude means this is the height from the mean value, or from the mean position. That means this is from P to here, we have this one is 3 unit amplitude. Now state the coordinate of the P and the coordinate of the Q. Clearly, if you see the diagram, this is the first maximum value and it is a sine curve. Sine curve, the first maximum value, and x is an angle. So this angle should be 90, and height, as I told you, that this is the maximum value, which is the amplitude of this equation, which is 3. So coordinate of P is 90 comma 3, and coordinate of the Q, which is Q, so you say that this is a complete cycle of sine wave, which is 360 degree, and this one is additional half cycle, which is 180 degree. So the total distance will be 360 plus 180, which is equal to 540, and of course there is no y value, so coordinate will be 540 comma 0. These are the coordinate of P and Q. So a different curve C2 has equation y equal to 3 sine x plus k, where k is a constant. The curve C2 has maximum y value of 10. Okay, the point R is the minimum point on the C2 with the smallest positive x coordinate. State the coordinate of R. Now if you see, this is the question about translation of the curve. That means a shifting of the curve left, right, up and down. And as you see that y equal to 3 sine x, you compare the original equation y equal to 3 sine x plus k. This plus k is showing that the curve is shifting along the y-axis. So this is your original curve, and you are shifting the curve k unit either above or below the axis, depends on the value of k. So we need to figure out first value of the k. So you suppose that you have a curve, something, this is the original curve I'm plotting here to show you. So this is the original curve. You know that this is this value is 3. Now this, they are saying that the curve has maximum value of y, maximum y value of 10. That means you shift the curve maximum value to 10. So 3, that means it should be moved 7 unit above to make it 10. 7 unit above. So you can imagine your curve has shifted something like this. So this value now becomes 10, maximum value. So this is the maximum value. And now, so that means the value of k is 7 units. Value of k is 7 units. Now, the point R is minimum point on the curve C2 after, no, this is C2 minimum point with the smallest positive value. So you see where is the minimum point of the curve with the smallest positive value of x. So the minimum value of the curve is this, which is R, point R is here. And you need to write the coordinate of this R. Clearly, you can see that this is the lower value, and this is the quarter of the curve, which is 90, 180, and 270. So coordinate of R, the x coordinate of R will be 270, comma, y value. Now, what do you think? What should be the y value? So you see that the curve has shifted 7 unit above. So this point was -3, and now it is shifting 7 unit above. 7 unit above. So what do you think? What should be the new position? It is 7 minus 3, which is equal to 4. So new position of R, or the minimum value, minimum curve, is 4. These are the coordinate of R. So 270, 4. It's better if you draw the graph to show your understanding. Thank you very much. I hope you understand. Have a nice day.